Thanks for coming to this JUG event. Actually, this is possible thanks to TSA development, just getting together, right, and talking about technology. So, yeah, Betfair and TSA development has some part of the event. So the next event will be the 14th of June, so take that date in your schedule, in your calendar. So we don't know what the event is going to be about, but at least there's going to be an event. All right, so today we are here to talk about the polyglot persistence with Spring Data. So Spring Data is an umbrella project for different data stores, right? So we're going to talk about a little bit about the support for JPA, support for different NoSQL databases. So how many of you used NoSQL databases here? Just a few of you. How many of you heard about it? Half of the room? Right, not bad. Okay, so Gavi couldn't make it because he's at QCon this week, right? So he cannot introduce me. So I'll introduce me myself, right? So I'm basically a Spring Source certified instructor delivering certified training for VMware, and I'm also part of the core of the team of the Java Hispano JUG, which is a JUG covering all the Spanish-speaking countries, not only Spain but also Latin America. And we do some events like Spring I/O. Spring I/O is an event which runs in Spain. So currently it's the biggest one in Europe because Spring 2GX1 is in the US, but here in Europe we got Spring 1 back in 2007 and 8, but we don't have any big events. So this is actually the biggest Spring event in Spain, right? So in Europe. So hopefully I'll see you there. It's going to happen. Still thinking about the dates, but it's going to happen somewhere in June or something like this. So if you want to visit Barcelona, right, so that's going to be a good option. All right, so if we think about where we come from, basically we have been using relational databases for quite a long time. That's a mature technology, right? So, but this has been evolving. Right? So basically we have the relational databases, we have all the analytical tools for business intelligence, and now, apart from that, we have NoSQL data stores. So we are using still the relational databases, but things evolve, and maybe in some scenarios, it makes more sense to use some other kind of data stores. So we have NoSQL databases, we have Hadoop as well to do MapReduce jobs. So we're going to be focusing, right, on these kind of new data stores. So what happens when we're using relational databases and we increase our data, our product, right? So everything gets complicated. So we usually denormalize the model. We stop using joins because joins are not performant. So we want to be as fast as possible. So we try to avoid them. We introduce caching layers, right? Because we don't have the performance that we want. So that's the next step. We implement custom sharding if that doesn't give us the performance. So all of these things are basically adding complexity to what we have, right? So this decreases our productivity just because we are focusing on all this stuff instead of focusing on the business logic, which is basically what we need to do, right, in our time. All right, so this brings me to the CAP theorem. Right? So the CAP theorem has three variables: consistency, partition tolerance, and availability. So it is said that for every single distributed system, we can only have two of them. So this is quite old, right? So it's not anything new. So we can see here that relational databases sit in this category, the CA, so they have consistency and availability. Right? So consistency is basically a guarantee that all the data is consistent. Right? So all the nodes, for instance, of a cluster will have the same data at the same time. Availability, so basically everything, all the data will be available whenever we request it. And partition tolerance is that we are able to add more nodes to the cluster without affecting the performance or the system in case. So relational databases sit in here, right? So they have consistency and availability. So usually NoSQL data stores drop either consistency or availability, so they focus on the partition tolerance. So all NoSQL data stores can be scaled, so they are built to be scaled. So that's actually, you get it for free almost. And basically, they drop one of these categories. So we see a lot of data stores here, right? So which one should we use? So maybe that's not the right question. So the right question, or the right answer, is basically use the one that fits your needs. So we have seen that, or we have been choosing for a long time now. So we had a lot of frameworks, right? So Spring is one of them. Right? So for instance, we had to choose a lot of MVSym frameworks, a lot of JavaScript frameworks, Ajax frameworks. So we have been choosing quite a lot. So now it's time to see what NoSQL brings us or gives us, and we have to identify when to use, or when is useful to use one of those data stores. So we take a look at the features of relational databases and NoSQL. So in relational databases, we have a relational schema. So we have a defined schema, so we build these databases with columns, and everything is defined up front. Whereas with NoSQL, usually we don't have a schema. So the evolution of the schema, or we don't have evolution of the schema, you can just put any data in there, and all the documents or all the data that's in there can evolve in different paces, right? So whereas in relational databases, if you want to add a new column, you have to update every single row that you have in the table. So there are like big companies, for instance, big companies, they have a lot of data, which said that just to put an extra column to a database took like more than a month, right? So they can't afford like changing the schema of the database if they have a system running for years, right? So like 10 years, and you have a lot of data. So evolving the schema is quite hard. So that's why NoSQL databases are a good fit, right? If you want to be more flexible in that sense. So relational databases have scalable reads. So usually NoSQL are best to build to scale. So they have scalable reads and writes. That comes almost for free. Custom availability for relational databases, of course, you can scale them. You can cluster them. But how many of you have clustered or scaled a database here? How easy was it? Okay, so you get that almost for free with NoSQL. So they are meant to be scaled, right? Clustered, sharded, right? So you have that for free. With relational databases, everything is really easy to query because we have SQL. So you can just forget about the data and just focus on SQL to query any data. But with NoSQL, you have to think about how the data is going to be used up front, right before storing the data, because that's going to be important because we have limited queries. So you cannot query the data as if you were in a relational database. Apart from that, we have the ACID principles with the relational databases, which we usually don't have in NoSQL. We have something called base. So usually the relational NoSQL data stores don't have transactions. So these are the main differences between relational data stores and NoSQL data stores. We have four main categories: key value data stores, column data stores, document data stores, and graph data stores. So at the end of the day, we'll be going through what's called a polyglot persistence model. So you won't be using a single data stores, but a combination of them. So you'll be storing some data in a relational database, so that works. So usually like 80% of the cases, a relational data store is the best fit, but you'll be combining that with other NoSQL data stores. For instance, here we have the e-commerce platform. So a key value data stores may be used to store all the data from the session, like the shopping cart and all this stuff. So you have all this data sharded, right, clustered. And I guess that if you have a scaled system, like sharing the session data is really difficult, right? So you have to go for sticky sessions and or any other approach. So this may be a good approach to go. Maybe we're going to use document data stores to store all the completed orders. We have a relational database where we have all the history and all the items of our warehouse, for instance. And we may have like a social layer, right, with a graph data store where you put all the relations from the customers and from any user in the system. So we take a closer look to the key value stores. Key value stores are like big distributed hash tables. So they are based on the Amazon's Dynamo paper, and they are nothing more than key value store, but they are distributed and really, really fast to query. They're fast to query, but they are kind of limited in the query, right? So at the end of the day, that's going to be like a key value store. So Redis is one of the implementations or one of the key value data stores, similar to Memcached, but the data set is not volatile, right? So we're going to have some kind of persistence in there. It has support for strings, lists, sets, hashes, so you'll be able to store anything as a value, for instance. You can also define a time to live value for this data. So at the end of the day, you can even replace your caching layer, right, by Redis, just because all the values may have a time to live, so it's kind of a caching layer. Master-slave replication, so I said, this distributed systems is basically what we're going to get with NoSQL data stores. They have like kind of transactions. We have said that NoSQL databases usually don't have transactions, but it has what's called batch operations, and it has support for different connectors. So I'm going to just open the Redis console to show you a little bit about it. Okay, let's see. You see that from the back? Okay, great. So I said, this is, well, the Redis console. So I said this is a key value pair distributed data store. So the only thing that you need to know is almost how to store values and get values. So I guess that all of you know how to use key value stores, right? Like a hash table, or let me see where I have it. So for instance, I'll be able to set data, right, in there. So this set operation, let me just put that. Let me just, oh, can't. So you see it from the back. Okay, so this set operation is basically setting a key value pair, right? So usually the keys in Redis have a colon. Right? So here we see that I set the key to user, Salmar, transaction, and 23 will be the value. Right? So when I hit enter, we're going to set a value, right, to the key value store. To retrieve that, I can use get. Right? So I get the user, Salmar, transactions, for instance. Right? I'm going to get this 23 right away. If I want to increment, I can increment atomically the value. But I said at the end of the day, we'll have key value stores, key value pairs with strings, lists, and well, all the supported values that we have just mentioned. So here's the increment. So if you want to increment that value, just call increment, and you see here that we got 25, 26, 27, 28. Other operations are basically setting a set. So here I'm going to define a set, which is the user Salmar friends, so that's the key. And notice that I'm using the sadd operation to add a set of friends. So I'm going to set 3 friends, so Josh Long, Jürgen Huller, and Alfredo Casado. And that's going to store a set for that particular key, right? So quite intuitive. So I'm going to add another set, and I can call sMembers, for instance, to get the members of a specific set. So notice that I have here, well, I have here all the members of that specific set. So I got 6 just before, or 5 just because I was testing before, right? So there are a lot of operations that can be done with these key value pairs. Okay, intersection, sorting, right? So a lot of things that can be done. Right? The intersection is one of the fastest things that can be done in Redis. Sorting. So I guess that you get the big picture, right? So just setting strings, lists, right? Anything as value, and well, that's going to be distributed. So that makes sense for a specific set of data. All right, so that was a really quick demo for Redis. So what about column stores? Column stores are based on the big table paper. So I guess that you have heard of it. Right, so it's nothing more than like key value pairs where the values are basically or can have different formats, different values. They may have like 3 values, 50 values, so they are based on columns, basically. Right? So Cassandra and HBase are some implementations. Usually, you use this kind of data stores for big data, right, processing. If we take a look at the document data stores, they are one of the most used ones, and they are the most similar to relational databases. In relational databases, we have tables, columns. So now we're going to have documents, right? So instead of having the tables, we'll have a document, for instance, which will have title, abstract, speakers, the topics. So usually that's going to be in JSON. So that's basically an example of a document. So we see here that we have different fields. So that's a JSON document, which can have like nested documents as well. Right? So here we see here that we have what represents a transaction. Inside, we have a user, payment details, and some fingerprints. So we'll be dealing with this kind of documents, right, the JSON documents. So MongoDB is one of the document data stores. So it's using JSON or BSON, right, for the storage of the documents. It accepts like updating the full documents or some parts of them, right? So partial documents. It has support for gridfs. So usually these documents have a maximum size, right, to be stored. You can't store like a really, really huge document. So gridfs basically takes large files and it splits it, right, in different documents. So you can just store and retrieve these large files. We have also support for indexing, right? So like we have in relational data stores, we have indexes. So we have here, or with MongoDB, we'll be querying data as well. So we're going to have the same support for indexing. It has also a rich query language, just because it's really similar to relational databases, right? So with Redis, we have seen that the support for queries is really limited because we only have like key value pairs, so we can just query data, but we can do a lot of complex queries, right? But in here, we're going to have a really good support for querying data. MapReduce, we have support for MapReduce jobs, even if it's not the best implementation of MapReduce jobs, so maybe you have to go for like Hadoop or any other tool, you have support for them for free. And replication and auto-sharding is also implemented there for free. So we take a look at the equivalence things from relational databases and MongoDB. So in relational databases, we have tables. MongoDB, we have what's called collections, right? Collections of documents, right? So a table has multiple rows. A collection will have these JSON documents that we have seen. We have indexes on both sides. We have said that we're going to query data, so it's going to be useful to have these indexes there to be more performant. In relational databases, we have joins, right, to join different tables. Usually in NoSQL data stores, we don't have joins because joins don't scale. And so in MongoDB, we have alternatives. We can embed documents inside other documents, so you can have all the data together, or we can even link documents, right? So that's going to be the equivalent thing, or we'll be able to do the equivalent queries and things with MongoDB. A partition in a relational database is going to be a shard in MongoDB, and the partition key, so basically how we do the partition, is going to be the shard key in MongoDB. So we see that more or less, right, we have the same concepts, but still, right, having all the benefits from NoSQL. If we take a look at how MongoDB positions in the space, we see that we have here two dimensions, right? We have functionality and scalability and performance. So relational databases give you a lot of functionality, but they are really difficult, or they are difficult to scale, right? And at the end of the day, if you have your data shared across different servers, right, you won't have much performance, right? Because if you have transactions, you need to synchronize all of them, and so on. So MongoDB is actually set here, so it's close to the performance of key value stores or even caches like memcached, and is also close to the functionalities that a database will give you. Right? So it actually gets the best of those worlds. Okay, so let's see a quick demo of MongoDB. Right. Okay. So as said, we're going to be storing documents, right, which will be JSON documents. So I have here a JSON document which I'm going to store. Right? So this MongoDB console is nothing more, or shell, is nothing more than a JavaScript shell. And so everything will be done in JavaScript. So how many of you are familiar with JavaScript? All of you. All right. I'm going to define a document. I'm going to assign it to this T1 variable. I see here the document itself, so that's going to be inside our T1 variable. I'm going to define more documents to be able to play around a little bit. So here's the second one. Great. And I'm going to be able to define what's called the collections. Right? So remember that in MongoDB, instead of having tables, I'm going to have collections. So this talks is going to be the collections. I'm going to store the value that or the document that I've just entered inside the collection. So I'm going to copy here T1, right? So I'm going to store that. So that's already stored, and the same for T2. Right, so now my talks collection will contain two documents. So let's see what's in there. Talks.find. Right, so we see here that we got two collections in that case. Let me see. Sorry. Okay, so notice that all the documents have an ID. So that's basically set by MongoDB, so you can have a document without an ID, and it's called actually object ID. So it stores everything in a format called BSON, so it's binary JSON. But at the end of the day, we'll be dealing with JSON. So we have a really a good query language. So using the find operator, right, we will be able to filter those documents. So it's more or less the same thing as using the where clause in SQL. So in here, I'm going to filter, right, by the topics. Right? So remember that a talk that I have here has a title, an abstract, a speaker, and some topics. Right? So I'm going to filter by topics. So in here, I'm going to issue this filter, and I got a single document, which is this talk that we are giving. Right? So basically, because the topic is NoSQL. I can have more complex queries. So I have these operators for not equals, greater than, right? So you have a full set of operators which you can use. So I'm going to filter all the talks by topic, which are not equal to mobile, for instance. Right? So in that case, I'm going to get the same talk just because it doesn't have mobile. So this one had mobile, this one didn't have mobile. Right? We have support for sorting. So we can sort by a field in the document. So title is one of the fields of the document. So I'm going to filter by those documents. Right, so here we got the, let me see what the title is. The title is here. So the first document I got is the multi-client development with Spring MVC. The second title is the polyglot persistent with Spring data. Right? So basically, they are sorted based on the title. More stuff that we can do. We can limit the documents that we want to retrieve. So that's basically applying a limit and an offset in here. So we just want to get a one result starting from the first result. So basically, we're going to get the second one, right, which is the polyglot persistence with Spring. So this is basically just to show you what can be done with MongoDB. So we have a full set of operators, right, to use with your documents. It's really similar to what we have in relational databases. Set. We have also support for index, so you can just define an index on a specific field of your documents. And you have also support for updating data. So in here, I'm going to define that I want to update. I'm going to update every single document which has the topic NoSQL, and I'm going to add a set, which is I'm going to add another property, another field, which is the data stores. Right? So in that case, I'm going to set an array of data stores, which are Redis and MongoDB. So this is how we add more data into the document without modifying the schema, because we don't have one. Right? So in a relational database, we should have created a new column, right, or a new table, right, in order to put these data stores. But in NoSQL, we don't have a schema. Everything's schemaless, so we can update the document right away. Right? So yeah, if I'm querying, or if I query the data once again, for instance, this one, I see here that I get the same object, and I have the topics field added to the document. All right. So let's go back to the presentation. So graph data stores. So graph data stores are basically a collection, right? So a database which is based on nodes and relationships. We only have these two things, basically, right? So nodes, which will connect with themselves, so we'll be defining the relationships within those nodes. So we carry data traversing the graph. Right? So by getting a node, and we're going to traverse it based on the relationships that it has. It has support for indexes as well, based on the nodes and the relationships. And it's written in Java. So you can even embed the data store, right, in your application. It also has support for kind of transactions. So let's take a look at Spring data. So we have seen that the 4 different categories of NoSQL. So now we're going to take a look at how to have a polyglot persistence layer, right, using Spring data. So we all know what the Spring Framework provides you. Right? So Spring Framework is basically a lightweight framework which will have support for dependency injection, has support for security, has support in the MVC, has support for accessing data stores. So we have a lot of projects around the Spring ecosystem. Right? So one of the new projects, or not that new, but one of the newest ones is the Spring Data project. Right? So at the end of the day, we'll have the Spring Framework and top all the projects that we're going to use in our application from the Spring environment, and everything can be deployed in a plain Tomcat, in a TC server, in a full-blown GE container. Right? So Spring Framework will maintain consistency regardless of the environment. So Spring Triangle. So this is the most basic concept behind Spring. Right? So everything is built on top of this triangle. So the main focus is the simple object. So the POJO programming model is the main principle. So we don't want to couple with the framework itself. We just want to have POJOs, business logic, and the framework will do all the stuff for us. So here we see the dependency injection. So the container will basically wire together all the components of our applications, so our applications can be decoupled and they don't have to depend with themselves. AOP is one of the other principles in Spring. So this is the way to add behavior on top of our application. So AOP is used for transactions, security, right? Whenever you want to add behavior or business logic on top of your existing components. And we have here the enterprise service abstractions, which will help us out in integrating, right, with different other enterprise services like JMS or third-party libraries like Hibernate. So Spring Data is the umbrella project for different data stores, not only for relational databases, because we have support for JPA and some extensions from JDBC, but also for all the NoSQL data stores that have come out lately. So for MongoDB, Neo4j, Redis, React, Gemfire, and even for big data like Hadoop as well. So the building blocks of Spring Data is sticking to the POJO programming model as well. So we're going to have the same principles as we have in the other projects in the portfolio. So we're going to have also templates. So I guess that if you use Spring, you're familiar with the templates. So you have JMS templates, REST templates, web service templates. You have templates all over the places. So they are basically some guys which will do all the job for you. So usually you have these one-liner methods and some callbacks to simplify the whole interaction with JMS or data stores. So in here, we're going to have like Mongo template, Redis template, Neo4j template, which will make really easy the interaction with those data stores. One of the main things of the Spring Data project is the repository support. So Spring Data, right, will create repositories for all the data stores transparently. So based on some interfaces, Spring Data will create those implementations for you. So that's common across all the data stores. So we'll have a common way to access all the data stores, so based on the repository support. So here's the repository interface. So we see here that this repository is parameterized. So usually you define what you want to persist, right? And the ID of the object that you want to persist. And Spring Data will create an implementation for any data store based on this repository. So this is the base class, but Spring Data comes with different extensions of that data class. Of that interface, sorry. So the CRUD repository is an interface which extends the repository interface, and it gives you all the CRUD methods, right, for free. So that means that as long as you define this CRUD repository or you implement this CRUD repository, you're going to have this save operation, find operations, like a count operation, delete operations, that for free, right, for every single data store. If you're using MongoDB, so Spring Data will just convert or will know how to store your documents, how to retrieve your documents. It will convert this object into the JSON format that the Spring or the MongoDB is requiring. The same applies to JPA. So that's actually a common interface that can be used for all the data stores. We have even more extensions of that interface. We have the paging and sorting repository, which is built on top of the CRUD repository that we have seen to give you paging and sorting. Right? So you can ask for a specific page, you can skip some documents, you can skip some data, right? And this integrates quite nicely with the MVC project, right? So in MVC, we'll be able to define these pageables, and this will be reflected in the data access layer as well. So here we have an example of implementing a repository with those interfaces. So here we have the person repository, which extends the CRUD repository interface. It's parameterized, passing a person, and the big integer will be the ID of the person. And apart from all the CRUD operations that that you're going to get for free, you can define more operations in the interface. So these operations or these methods are going to comply with some conventions. Right? So this finder method is going to create an implementation based on the convention on the name. So find by email address. So that means that email address is a property of the person object. So it's going to create an implementation where it's going to bind the email address to that value. Right? So this is actually, we're not specifying whether we're using JPA, MongoDB, or any other data store. So Spring Data will take care of converting that into the query language specific for that specific data store. The same applies to the second method, find by last name, like. So we have some keywords which you can use in those names. And the same applies here where we get, right, some pagination on top of the query, right? So this is a paging or a pageable object which contains the offset and all the data for paging. Okay, so let's focus on JPA. So how can we make it work? So given the interface that we have seen, we'll be annotating our objects, right? So you know how to annotate the objects, how to use the JPA annotations. So we have the entity annotation, which will define an object as a persistent object. All of them will require an ID. So we have here a big integer, which is annotated with the ID, and it's actually a generated value. We have here some other metadata, like the column where to map the email address to. We have some mapping for some collections. So this is our domain model, which is annotated with the metadata for JPA. So what happens, or how can we retrieve, or how can we create repositories for that specific model? So we have seen the interface already, which is this one here, right? So Spring Data will just will implement the interface on the fly, right, at runtime. So using this JPA namespace and scanning, right, all your class path, right, for repositories. In that case, we're going to scan this com java2days.repository, right, in order to find repository interfaces. If we find them, Spring Data will create, right, an implementation for you. So you'll have all the CRUD operations for free, plus all the implementations for these guys for free. All right, so what else can we do? If you don't like the conventions and you want to define your own JPA query, you can do so. On top of the method itself, you can use the add query annotation. So query annotation accepts, right, JPA query, so in JPA query language. So we see here that we select everything from person, where the email address is like 1. So this one is the parameter that's going to be taken from the method itself. And the second example is actually using named parameters. So we see here that we have 2 parameters, the first name and last name, and we are binding them to the arguments passed to the methods. Okay. So either you rely on conventions, you define the query right away here, or you define also the unnamed query, which you can define somewhere else, right? In a property file, that can be done as well. Right? So there are different ways to define the query that you want to do without, right, having any implementation. All right, so if we take a look at the document data stores, right, specific in MongoDB, we have support, or actually we have the same components, like the template, for instance. We have support for mapping from object to document. We have the same repository support, so we'll be using the same repositories interfaces. We have a query DSL to have a type-safe query, more or less. Support for JMX, logging, geospatial support. So that's really interesting, right? If you want to retrieve data which is like near some location, for instance. So that was a request of Foursquare. How many of you use Foursquare here? 2. Okay, so actually Foursquare and MongoDB were in the same building, right? So, and Foursquare is a user of MongoDB, so they requested this feature, and they built this feature for Foursquare in that case. And support for namespaces in Spring. We have seen the JPA namespace. Now we're going to have a MongoDB namespace. So, as we did with JPA, we're going to add some metadata, right, in our domain model. So we have this add document annotation, which will define that this object will be like a MongoDB document. We have the ID. We have like different other annotations to define metadata with for MongoDB. So at the end of the day, you'll be doing that either for JPA, MongoDB, right? So you'll be providing those this metadata. You have been doing that for a long time. And templates. Mongo template has some convenient methods to interact with MongoDB. So it has support for callbacks if you want to have more power, but you have these one-liner methods to find data, to save data, to delete data. Right? So here we have a find method where you can define a query, right? So a query which is more you define the object that you want to retrieve, and you're going to get a list of those objects. You have the save operation. So basically, it has convenient methods to interact with MongoDB. So how can we use the Mongo template? Right? So quite easy. We define a new Mongo, so that's basically going to create or define the MongoDB. So here we have the factory, which defines the database. And this is basically what we have to inject in the template. So you know that templates require something, right, to access the data store. So that data source, or actually the JDBC template requires a data source. If you're using JPA, it requires an entity manager. So at the end of the day, we'll have to provide some means to get access to the data store. So the Mongo template requires this factory, the MongoDB factory. So now we're basically going to create an object which may be annotated with some metadata, and we'll be able to store the object using these one-liner methods. So notice that it's quite easy to get something stored in MongoDB. So just template.save, and you'll get the job done. The same applies to the find method. So this find method accepts a query, and this query can define some kind of criteria. So we're defining that the email needs to be dave@dmband.com. We take a look at the repositories. So they're going to work the same way. So we extend from the repository interface. We can extend from the CRUD repository interface. We can extend from the sorting and paging repository interface. So it works the same way by conventions, by default. So we extend the repository interface, and all the methods here will work by convention. So this finder method will be implemented based on the name. So we're going to match the email address to this string here. So this will create, right, a MongoDB query. Right? So Spring Data is going to do that for you. The same applies to this guy here, find by last name, like. So all the keywords that could be used in JPA can be done in MongoDB as well. So at the end of the day, Spring Data is going to be responsible to create the corresponding query for the corresponding data store. Right? We have also support for geospatial queries, like find by location near, a point, and a distance. So at the end of the day, this is the query, right, that Spring Data is going to create for you. Right? So it's going to say, hey, I want that the location field has to be near the point XY with a maximum distance of 50 kilometers, for instance. So here's the keywords that can be used. So we can use the greater than, less than, between, not, no. Right? So these are the keywords that can be used in the names. So we have here find by last name. This doesn't have any keyword, but you can actually have as many keywords as you want, right, in your finder method. So at the end of the day, if you have a method like find by age greater than, this will create a query with age greater than and the parameter that you are specifying. And this actually applies to JPA and all the data stores. Right? So Spring Data is responsible to create the define their methods. All right, so here we see a usage of a repository. So you just need to define the interface, like this one here. So using the Mongo namespace, Spring Data will create at runtime the implementation for those repositories, and using like a Spring component, right? Like this one here, you'll be able to auto-wire or to inject the person repository in that case. So this will comply with the interface that we have defined, but the implementation is going to be done by Spring Data. And you'll be able to call the methods that are there, like find by location near, right? So you define a point with a distance of 200 kilometers, and this will trigger the corresponding MongoDB query. All right, if we take a look at Redis, right, it's going to be more or less the same thing. We have support for different connectors like Redis and JRedis. Right? So there are actually different libraries out there which can connect to Redis. So we have support for some of them. We have the Redis template, which offers you a way to interact with different values like strings, hashes, sets, and basically everything that can be stored inside these key value pairs. It has a fluent query language. It has also support for public subscriber messaging, kind of. And also it has support for the caching abstraction layer. So in Spring 3.1, a caching abstraction layer was introduced. Right? So basically, using the add cacheable annotation, you can annotate any method, and this can be backed by a caching strategy, which may be a hash map, or maybe Redis, or maybe Gemfire, or anything that you configure in your application context. So here you see the Redis configuration. I don't know if you see it from the back, but what we define here is the connection factory. So as said, we have support for different connectors. So we're using Redis here. So we're defining where the save is, where the port is. This will create a connection to Redis. And this connection factory will be injected to the Redis template. So again, the Redis template just needs, or the template just needs to know how to connect to the data store. So here we have the usage of the Redis template. Redis template has operations for values, operations for sets, operations for hashes, right? So all the available data types that we have in Redis. So here we have the get operation, basically the one that we have seen on the console. We have a set operation to set some values. We have support for incrementing values, support for adding to a set, to intersect to different sets. So basically everything that can be done in the console is available through the template. Okay. Great. So that's everything from my side. So we have seen more or less how to, or the different data stores that are available in the NoSQL space, like columns, right? Key value pairs, documents, and graph databases. We have seen that Spring Data is the umbrella project which accepts, right, or interacts with every single data store, not only relational databases, but all these NoSQL data stores. And the main building block is the POSIX programming model and the repository interfaces, because with those repositories, Spring Data will be able to create, right, the implementation and query data and store data for all the data stores with the same API, right? So with the same interfaces. CRUD for free, right? Paging for free. So you have everything for free, like the bases, right? So you just need to add new methods based on conventions, modify them. You can actually implement, right, methods on those interfaces. We haven't, or for those interfaces, we haven't seen that. But you can combine different interfaces and have some implementations for specific methods, right, in your repositories. Right? We have only seen the interfaces, and basically we have let Spring Data to create the implementation for us. But you can actually, it's really, really powerful, and you can add any implementation on those. Question there.
Two, in fact. The first, how does Spring NoSQL compares to Hibernate's OGM? And the second, how do you plan to expose specific functionality? For instance, columnar or breadth or whatever via a generic API, a specific functionality, or a specific NoSQL.
So there's a support for like using the same JPA annotations for graph data stores, but I guess that this is not the best thing to do, right? So JPA or traditional data stores are meant to work in some way. Graph data stores are meant to work in another way. So having like a common API is really difficult, right? And it may not be the best thing. So even if there are efforts going towards there, right? It may not be the best thing to do because they work differently, right? And we have a common API for, interfaces for JDBC, Mongo, and all these guys, right? But using the same thing from JPA and Graph is kind of hard in that.
Basically, I will still be forced to use specific clients in order to access specific functionality. Specific API plus Spring NoSQL.
So, you can do that, right? Having a common API, but at the end of the day, that's not natural to the developer, I would say.
Do you support NoSQL solutions one by one? If I want to use Cassandra or something else or YUG, do you support?
So there's like the main support, right? Rike is supported as well, but there's a lot of community efforts. So you're gonna see a lot of implementations for different data stores coming from the community as well, right? So if you want to implement your support for your data store, right, and it's not there, right? So the common API is there, right? So it's quite easy to just plug in some of the data store in that common API.
In case of different data stores of different types, let's say Workmania, and based, you will use different annotations.
Different?
Can I have a mix repository like an API that will go to the GPA and one API will go to the Mongo template?
The same repository?
Yes.
No, because the namespace is scanning a base package. It's taking the interface. It's basically getting it and doing the implementation for you. There are ways to do that, right? If you provide your own implementation. So imagine that you have like 3 interfaces and you implement one interface, right? With JPA access, another interface with like MongoDB, and you kind of mix them inside a repository, traditional repository. You you can do that, right? But if you mix like CRUD repository in between, then it may be difficult. But you'll be having the CRUD operations for JPA, but you'll be extending a little bit the repository, right, and providing the MongoDB solution for or implemented by you, right, not coming from the support from Spring Data.
Coming back to Hibernate OGM, is there any plan to Spring Data to bring something similar or something?
I'm not aware of it. Right, so Spring doesn't want to reinvent the wheel. So usually it tries to embrace what's in there, right? So it tries to integrate it with third-party libraries, but coming from Spring itself, right? So I'm not aware it's anything like that.
With MongoDB, is there a way to Spring Data to translate more complex queries that need to do the aggregation service?
So the aggregation service is quite new in 2.4, right? So I haven't tried it with Spring Data, honestly, but I don't think there's support yet. Right? It's quite new. It's like from the latest version of Mongo.
One question. In Spring Boot, do you have support for Spring Data or you by event? Data flooding?
I was trying that, right? Because, but I couldn't find it. Right? Even if I've seen some places stating that there's support, I haven't found it. Actually, I have only found the basic JPA support, right? Which you configure the persistence, and it comes with the basic JPA support that you had previously with Spring Boot. So as far as I know, there's no support for that. But it won't take long until we have. All right, so thanks for coming. All right, so and reserve the data I showed you, which is like 14th of July, if I'm not mistaken, right, for the next event.